Welcome back to Python and Excel 19.4. So far in this mini-series, we've extracted the titles for each table, collapsed the headers, worked through some wrong assumptions, and now we're going to find a way to categorize the different types of data rows. As a reminder, we're dealing with a data file with 215 tables. Here's one of them. Each table is divided into what I've called row types, T for the title, H for the header, D for the data rows. Then within the data rows, there are many empty rows. There are also in many of these tables subheadings, 2018 data and water resources regions. These serve to separate the different types of rows from each other, but as we saw in the last video, we don't actually need them. This is the state of the function from the end of the last video. This getRowType call will return only the D rows from whatever data frame has been passed to get table data. Then we're removing blank rows where columns indexed 2 or greater are blank, removing rows that contain the subheaders mentioned a moment ago, and returning what's left. So the goal here is to be able to categorize each of those remaining row types. You can see the categories we're going to end up with on the screen here, but just to check that all values in that column conform to these categories, we'll first get all the D rows from every table by using getRowType on dfraw with rowtype D. Then we can inspect the unique items in column 2 by using the numpy unique method. It returns an n-dimensional array. Convert it to Excel values with Ctrl, Alt, Shift and M, and there we have it. The green rows are states, the orange rows are water resources regions, yellow is crop, and finally blue is the farm size ranges. We need to determine some way to assign a D row type for each of those values. Before we do that, let's hop on over to VS Code where I want to show you a simple way to get US states. In Python, there are many ways to crack a nut, but an easy one to get a list of US states is to use the US package. If we simply get the us.states.state property, we get a list of state objects. That's not exactly what we want, but if we access the state.name for each state in that list of state objects, we get a nice list of US states. Sadly, the US package is not available in Python and Excel at the moment, so we will have to deal with it in a more static way. Let's hop on over to Excel and see what that looks like. I've defined a few objects in this Python cell, a list called US states. This is just a static list of the 50 states. I've written the variable name in capitals since that's a Python convention for defining constants. Another constant I've defined here is a list of exclusions. This currently contains those subheadings mentioned previously. Defining it as a constant here means we can add or remove items from it later in just this one place. Finally, I've placed the constants into this dictionary called metadata along with the year for the dataset. Doing this means whenever I need to check something against the list of states, I can just pull the list out of the metadata dictionary, or the year, or whatever I need. To keep things organized, let's define a function called categorize_rows. It will accept a pandas series called S, that's just the column of row headers in the D rows, and a dictionary called metadata, to which we'll pass the metadata dictionary we defined earlier. It'll return a series, i.e. another column, which will contain a D row type. To make this happen, we're going to use the select method from the NumPy library. If you're not sure about the details of how that works, I urge you to watch video 22 of my Python and Excel series. To use that select method, we'll define a list of conditions, one for each of the expressions that define one of the D row types, and a list of choices, again, one for each D row type. The first condition will be S is in metadata US states. If the row header contains a US state, this will return true. Next, we'll use the same is in, but this time metadata exclusions. If the row header is any of the items in the exclusions list, this will be true. If it starts with the word region, this third condition will be true. We put fill NA false at the end here because using a string matching method like starts with returns NA if the input is NA, and that's no good for what we're trying to do here. If it's just the text United States, this fourth condition will be true. If the row header is in either of these two, farms or an empty string, then this one will be true. That will be mapped to the text other. Lastly, we'll use string.match and a regular expression for begins with a digit, but negate it with a tilde at the beginning, essentially making this does not begin with a digit. This will be mapped to the word crop. Next, we create a list for the choices for each condition. We have 6 conditions, so we need 6 choices. Finally, the result is np.select conditions, choices, and we'll use other as a default value. And then let's just put a message at the bottom to display in the cell so we know what we're doing, and we're good to go. Let's see if this new function has done the trick. we'll just create a data frame that puts the unique items being categorized next to their assigned categories. That's just applying the new function to the series containing the unique items. Alright, here it is. States look good, subheadings look good. Okay, this is a problem. These water resources regions have been categorized as crop. We'll need to fix that. The crops seem okay, and the farm size ranges have all been categorized as other. That's okay, not ideal, but not wrong per se. For those water resources regions, I suspect it's because Python is case sensitive and I've mistakenly put lowercase r on the region in the starts with method. Let's just change that to a capital R and see what we get. We're checking to see if these have been categorized properly, and it looks like they have. Great! Now we've got the beginnings of our categorize rows function, we can add it as a step to the getTableData function. We'll just make a copy of the earlier version and add the new line. Going forward, we're going to be refining this function, so we'll need a repeatable way to test what it's doing. Let's define a function called testGetTableData. It will accept a data frame and a dictionary and return a data frame. It's quite a simple function. It just executes the getTableData function, then returns the row header column alongside the dRowType column. We'll just use drop duplicates to make sure we're only returning enough information to decide whether it's working or not. Now we've got that test function, we can use it with the current version of the getTableData function. Okay, something wrong here. It says unexpected keyword argument metadata. Right, that's because this new version of the function doesn't have a metadata argument. It's easy enough to add that and try again. And let's look at the result of the test. Okay, so the main problem here is that we have this none row which has been classified as crop. Let's dig into that a little. We'll start by just processing dfraw, and then we'll filter it using dfloc for where the dRowType is crop and column index 2 is NA. And we'll return just column 2 and the dRowType. On second thoughts, that's not that helpful. Let's add column index 3 in there as well. All right, what have we got here? Let's look. Looks like a lot of rows with blank column 2, 2013 in column 3, and crop in the dRowType. If we just zip over to the raw datasheet and take a quick look, we can see that in quite a few of the tables there are these country level summaries at the top. And there's two rows, one for the current year and one for 5 years prior, which happens to be 2013. So it's pretty clear here that the value in column 2 should be United States. So let's add a way to update those rows. It's important in situations like this to be pretty specific and to get the parentheses just right. So we'll create a mask that says where column index 3 is equal to 2013 and where the shifted value in column 2, i.e. the value in the row above, is equal to United States, and the shifted value in column 3, again the row above, is equal to the current year, which remember we have in that metadata dictionary. So that's the Boolean series which we'll use to filter the data frame. We use dfloc again with the mask and column index 2 and set it equal to United States. Now, when we rerun this cell, we find that the only remaining issue is these rows, where column 2 is blank, dRowType is crop, and column 3 is the word acres. Since these lines for updating those 2013 rows are good, we can add them to the getTableData function now. Let's make a copy of the function in a new cell, and while we're at it, let's rename some of these steps. Starting to get a bit messy. We'll add the new lines and rename the data frame objects. And instead of hard coding 2013 in here, we can just use metadata year -5. The assumption is that if we receive a version of this file in the future, the difference between these rows is always 5 years. I think that's probably a safe assumption for now. Actually, I think these lines need to be moved above the categorize rows function call. We can rerun the test and inspect the output. The only non-crop rows are now down with the farm size range data, which is to be expected given what we saw previously. So let's investigate those non-crop rows. We can do that easily by just filtering column index 2 on isNA. Well, okay, that's not super helpful. Where are columns 0 and 1? Okay, let's recreate dftemp just in case we've messed it up somewhere earlier. This is one of the dangers of using names like dftemp. Do not recommend. Still the same problem. Let's take a look at the getTableData function to see where those columns are getting removed. Oh yeah, there it is. The second line in this function is filtering first and then dropping the rows. The result of that is it's effectively removing columns 0 and 1 at the same time. Okay, we can comment that out and do it another way. Instead of iloc, we can apply drop NA directly on the D rows data frame, but this time put the filter inside the method in this subset argument. So only drop the subset of columns from index 2 onwards where they're all NA. Now we have column 0 and 1 in our latest investigation, which is useful because that shows us that this remaining problem is only in table 215, which should make it easier to figure out what to do. So let's filter the D rows on table 215 only. Okay, that gives us the D rows for table 215, where it's pretty clear what's happening. A hierarchical row header where each of total farms and the different farm size ranges has a row for number/farms and a row for acres. So what we need to do is fill down into those blank rows, but we need to be cautious with fill down, which is done with the ffill method. We don't want to fill down anywhere else unless we know that's exactly what's needed. So the logic to control this next operation is going to need to be quite specific. I've made a copy of the getTableData function. Let's first do some tidy up. Wrap these conditions for this mask, use the metadata exclusions instead of the hard-coded list. First of all, let's write out what's needed as a few comments so it'll be easier to figure out. Looking at the data shown on the sheet to the left, we want to return all those rows without referring to the table ID 215 because it might not be that table ID in subsequent or prior years, or there might be more than one table with this layout and we'd want to capture those as well. So we need to filter the D rows based on the values in columns 2 and 3 alone. It's either acres in column 3, and on the row above, i.e. the shifted version of the series, either column 2 contains the word acres or column 2 is equal to farms with a capital F. That captures the rows with the none in them, but we also need to capture the other rows as well so that we'll have something to fill down into the blanks. So the second mask is column 3 is the word number. That's the first row of this layout, or column 2 contains acres and column 3 is farms with a lowercase f. We can then combine both of these conditions with an OR operator to create a single mask that we can use to filter any data frame passed into this function, which is done like this. We apply the filter, then use the ffill forward fill method to fill down the non-blanks in column 2 into the blanks in the row below. Now that we've added that code, let's verify that it does indeed work on table 215. Yep, looks like it's done the trick. Now let's rerun the test function on the whole dataset. Okay, all of that looks good. Down here at the bottom, the none crop row is gone, but these are still categorized as other. I'd like them to be farm size range. To deal with that just takes a small change to the categorize rows function. So this fifth choice is farm size range, and that's assigned when the fifth condition is true. Currently the fifth condition is if the text is in farms or empty string. We just need to add to that, or if the text begins with a digit, like this. Executing that updates the sheet, and checking the bottom of the test shows that across the whole data set, wherever these values are found beginning with a digit, they are assigned this farm size range value. That's it for today. These videos are proving somewhat time consuming to produce, but I hope to continue this journey, which is getting near the end now, you'll be pleased to hear, in the next week or two. So thanks for watching and have a great day.